Let's solve for Pythagorean's theorem using some basic visualization and some basic algebra. So let's say we have a triangle, I don't know, that's a right triangle that's got two sides of 2 and 5, and we want to solve for the hypotenuse. So we're going to take and we're going to draw this triangle here, sides of 2 and 5, and I'm going to go ahead and put some labels on here. So this side will be B, and we're going to say that equals 2, and this side will be A, and that equals 5. So next, we're going to take and visualize this by rotating this triangle around. We're going to rotate it 90 degrees to the right and mate the short side with the long side here. So here we go. So here we have another triangle that's 2 by 5, and another one that's 2 by 5, and one more that's 2 by 5. And I should have probably labeled this too. Here we go. Here's our C. And we don't know what C is yet, right? And so we know from looking at this now, from our definitions, we know that B is 2, this is also equal to B, this is also B, and this is B. So we know a couple things here. We know that the length of, we still don't know the length of this side, but we know the length of this side right here, this long side, is A plus B, right? And we also know, I'm going to go and label all these. We also know that this is a perfect square. So we can say that the area of this outer square is A plus B quantity squared. So I'm going to go ahead and outer square area is A plus B quantity squared, which equals A squared plus 2AB plus B squared, if you remember your basic algebra. And you can solve that somewhere else if you don't. So with that said, we've got it partially solved now. So we still don't know how to solve for C. So here I'm going to take this triangle and I'm going to fill it with, I don't know, I'll make it red. And then I'm going to take and draw another triangle right here. And I'm going to fill that with, I don't know, not red, maybe blue. Okay, so now we have this rectangle with that's half red, half blue, because we know it's half, because these triangles are equal, right? So, so now we're going to say rectangle area is A times B. We know the area of a rectangle is length times width, right? So now we have something interesting here, because we know that this red area, I'm going to go ahead and add a note here for that. I'll write it down here. What the hell? Let's see. Red area is 1/2 A times B. A times B. Or you can say it's A times B over 2, right? And so now it starts to get a little interesting here, because you can take this and this and this, if I can use the software here. And we also know that these triangles are all equal. So now we can say 4 A times B over 2, 4 times that, is the red areas. So, 2A times B. Or I guess I could just write it as 2AB, right? So now we go back up here and we look at this. So we know the outer square area is this. Now we can go and take and subtract 2AB from that. So it'd be A squared plus 2AB plus B squared minus 2AB, which is a squared plus b squared, and that is what's left over, which would be c squared. That's it.